I know, even when I'm not. Okay. So what does at most 9 mean? Like at most 9 are defective. So if I've got 10 people and I want at most 9 of them to be taller than 7 foot tall, what does that mean? If you go to Denny's and you can eat off the kids menu, if you are at most 12, can you be 13 and eat off the kids menu? Okay, so what does at most 9 mean? You could be 9 or 8 or 7. Cool, right? And this is actually something from algebra. How do you set up the inequality for that? It's going to be less than or equal to 9. So at least 1 is anything from 1 up to the total number. Cool. So if I have 10 things, how many of them could go wrong? 0 through 10. But if they were more specific, at least 1, well, that's 1, 2, 3, or 4, or 5, or 6, all the way up to 10. That would be at least 1. Okay. Yeah. 15. So if the probability of randomly selected car crashing during a year is 0.048. Number 15 on 4-5. Wow, and that's higher than I would want it to be. I mean, that's almost 5% chance. That's unusual, but just barely, right? It's almost 5%. Yeah. So we're including everybody that's driving these cars. So if a family has 4 cars, find the probability that at least one of them has a crash. So we have 4 cars. Find the probability that at least one crashes sometime over the next year, I think. Yeah. So there's a 4.8% chance, a 0.048 chance that a car will crash. If I have 4 of them, what's the probability at least one of them will crash? Now, I desperately want you to understand what we just talked about. So what does it mean? How many do I want to have crash then to answer this question? At least one, meaning 1, 2, 3, or 4, right? And I really want you to understand, if you try to do that directly, how many ways can one car crash? It could be the first one, or the second one, or the third one, or the fourth one, right? So I got 4 problems just to do probability of 1. But at least 1 means 1 or 2. How many ways can 2 car crash? Well, it could be the first 2 or the last 2 or the middle 2 or this 2 and that 2 or, oh my God. So now we're talking about a stupid amount of work to answer what sounds like not really that evil of a problem. So somebody was over there was saying, why are you doing all the crazy stuff, Jeff? At least 1. What's the opposite of at least 1? None. So really, they ask you this question, but that's the same question as 1 minus the probability that none of them crash. All right, that's step 1. It's just to figure out a better thing to calculate. Don't calculate what they ask for directly when they say at least something. Think about it for a second. Is the opposite quicker? If the opposite situation is quicker, hell yes, I'm going to do the opposite situation, right? That only makes sense. But what does it mean for none of them to crash? What does this 4 tell me that I can do down here? So now I've got 1 minus, how do I calculate none of them crashing? So how many cars do I have? 4 of them. I want the first one to do what? Not crash. And the second one to not crash. And the third one to not crash. And so I try to really get, when you say you have 4 cars, you've got 4 spots to fill, right? 4 spots to fill. You want the first one to not crash. What's the probability it doesn't crash? Careful. I saw a lot of that too. I saw like there was a problem in the homework that says 0.25%. What's the opposite of that? It's not 0.75%. 0.25% is 0.0025, and if you add 0.0075, I don't get 1, right? So if the probability of crashing is 0.048, what's probably not crashing?
952.
I love it. 1 minus that? 0.952. I love it. So the first car doesn't crash. I don't want it to crash. So that's 0.952. And the second one doesn't crash. Do I have to change the probabilities as I go through this? Why?
Because you take out more factors.
So you might think I might have to, but how big of a population are we talking about? Very large. How many people drive in the United States? Well, just around here, it feels like the entire United States is driving on our roads. I don't know if you feel the same way, but I do feel that way. So yeah, so I don't have to change as I go through. I've got a very large population. I'm only taking 4 of them. That's definitely less than 5% of the whole size, right? How much is going to change? Not very. And I see a little too much of this, like 67%. Somebody says that's 67 out of 100, so then if you have to multiply, it'd be 66 out of 99. But if I'm talking about 67% of Americans, are there only 100 Americans? No, so this doesn't make any sense. It'd be something out of 310 million. It just reduces to this, right? So you'd have to make it out of 310 million to make this 309,999,999. Why do that? Because they don't change that much, right? So that's the 5% rule that says, why would you change them since they don't change much at all? Don't change them. So I want this one to not crash, that one not crash, and that one not crash. So I'm hoping some of you guys kind of pair this up with what we did recently, that binomial probability theory. I didn't have to write it like that. I got 1 minus 4 cars that don't crash, 4 not crashing cars, right? And I just got to do that. Now, the other part of this problem, is that okay there? So it's a key word to look for. If they say probably at least 1, or even at least 2, I want to do 1 minus the opposite, right? The opposite, oh, now I'm really pushing my luck here. But what's the opposite of at least 2? What's at least 2 mean? Like if I had 80 people and I want at least 2 of them to be right-handed. What could that be? That could be 2 or 3 or 4 up to 80, right? So what's the opposite of that? What's it leave out? 0 or 1, right? So if I just do 1 minus probably a none, minus probably a 1, what's left over is 2 and up. The opposite of at least 2 is 0 or 1. So I could do 1 minus that probability, get that quickly. It doesn't just work with at least 1. It works for anything. So if they ask me for the probability of something, and the opposite probability is easier to calculate, hell yeah, I'm going to calculate that and do 1 minus